All right, naming with oxidation states we've actually done before. This is how we name compounds with transition metals. So magnesium 4 oxide, the Roman numeral is telling you the oxidation state is +4 in this compound. So for transition metals in binary compounds, or transition metals that are not a part of the polyatomic, their charge is the same as the oxidation state. So we can say magnesium for an oxygen -2 when we cross our charges would be Mn2O4, and then we can reduce to the appropriate formula. So oxidation numbers and the charge of transition metals are the same if they're in a binary compound or they're not in the polyatomic portion of a compound. So if we look at number 1, we know oxygen has an oxidation state of -2. There's 2 of those, so that's like a -4. So we would need lead then to be a +4 to balance that and give us a neutral overall charge. So this would be lead 4 oxide. For number 2, chlorine is the most electronegative, so we're going to give it the oxidation number of its charge, -1. There's 2 of those, so that's -2, so tin would be a +2 to balance that. So this is tin 2 chloride. Hopefully you're going to pause and work through the other 3. For number 3, chlorine is the most electronegative, so we're going to give it its charge for the oxidation number. There's 3 of those, so that's a total of -3, so the antimony has to be +3. So this is antimony 3 chloride. Now when you're typing these words, the Roman numeral is usually right next to the metal, or you can do a space in between. Either way is appropriate, but the Roman numeral should be in parentheses, especially when you're typing them. All right, so again, we're going to go with the chlorine as a -1. There's 4 of those, so that's a -4. So titanium then has to be a +4. And finally, fluorine is always a -1. There's 5 of them, so that's a -5. So that means bromine here is a 5. So sometimes you might see the transition metals written with the Roman numeral as the oxidation number for that. That's not as common, but just in case you see it out there, that's what that is.